Okay, in the next few videos, we're going to go over everybody's favorite topic, factoring. So when we are factoring polynomials, what we are trying to do is to break a single polynomial into the multiplication of several other simpler polynomials. Okay, so the first kind we're going to go over is, or kind of factoring we're going to go over is factoring out the GCF, or greatest common factor. So this is something that you should always do first before you try any other type of factoring. Is you should always look to see if there's a common factor that you can take out of all the terms. So if you look here, I've got four terms: 2x to the fifth plus 4x to the fourth minus 6x cubed plus 2x squared. So I'm looking for any factors that go into all four terms. So first, let's just look at the coefficients. 2, 4, 6, 2. Obviously, 2 goes into all of those. So I'm going to be able to undistribute or take a 2 out of all of them. Okay. Next, let's look at the exponents on the variables. I got an x to the fifth, x to the fourth, x to the third, x to the second. So all four terms have at least an x to the second in them, so I'm able to take out an x to the second. Whatever the smallest degree term is, you'll be able to take that out. So now we got to figure out, okay, what's left over if I do take this out. If I take a 2x to the second out of 2x to the fifth, I've divided out the 2, all that's left over is x to the third, because x to the fifth divided by x squared is x to the third. If I take a 2x squared out of 4x to the fourth, 4 divided by 2 is 2, so there's a 2 left as a coefficient. And x to the fourth divided by x squared is x squared, so I got a 2x squared left. Next term, I got negative 6. If I divide that by 2, I got a negative 3. If I take x cubed divided by x squared, I have 1x left. Like 3 minus 2 is 1, so x to the first. Lastly, I got a 2x squared. That's exactly the term I took out. Now be careful, because the mistake I see a lot is students will just, okay, well there's nothing left, so I'm just going to end the problem right there. But think of it like this. If I take 2x squared and divide it by 2x squared, there's actually not nothing left, there's a 1 left over. 2x squared divided by 2x squared is 1. So you have to have a plus 1 as a placeholder. A good way to double check your answer on these greatest common factoring ones is, if you were to multiply this, if you were to distribute this back through 2x squared, like distributed across the parentheses like so, would you get back to the original problem? And in this case you would. Okay, so this right here is factored out the GCF. Alright, so let's look over here. I got three terms. Each term has at least some w's and some z's. So let's look what I can take out for w's first of all. I got a w to the fifth, w to the first, w to the second. I can only take out the smallest degree, so I can only take out a w to the first. I got z to the second, z to the third, z to the second. So two of them are tied for last with 2 or z to the second, so I can take out a z to the second. Alright, so then what's left over? At this first term, I took out one of the w's, so there's a w to the fourth. I took out all the z's, so there's no z's left. This one, I took out the only w, and I took out 2 of the z's, so there's only one z left, and it is minus z because there's a minus out front. This term, I took out one of the w's, so there's a w left, but I took out both z's, z to the second, z to the second, so there's no z's left, so that is it. So factoring out GCF is basically just using, the division rules for exponents and taking out as many factors as you can. It's as simplified as it can get when there's no, if you look at the inside of the parentheses here, there's nothing that I could take out of all three terms, okay? Because they don't have any factors in common. There's no coefficients, first of all. The coefficients are always 1, and now they don't have any variables in common either between all three of them.